Yeah, welcome to VLSI YouTube channel. So today I want to explain about the remaining data types. Those are nothing but Reg data types and vectors, what are vectors, and arrays, okay, integer data type. Okay, so this net data type and reg data types are nothing but unsigned data types. So that's why in order to store these values like negative values, those are in terms of post complement, we'll go for integer data type, and one more data type is float data type. In order to store decimal values, we'll use the float data type. So first of all, we'll see the today these data types. Okay, one second. So first is reg data type. So reg data type, this data type, by using this data type, we can store the data. Okay, we can able to store the data, able to store the data. So we already seen the netted data type that like wire, var, wand. Okay, so by using netted data type, we can't store the value. Just we can drive the value. Okay, so we can drive the value. So example, if you see module, module example, reg x, reg x, initial initial. If it is only one statement, begin is not required. Just initial and end module. Okay. So here we initialize. Sorry, here a reg a. Okay. So reg a. So reg a means what? So here whatever the zero value will be there, that will be stored in the variable a. Okay. By using this, we can store the value, whatever the value, either it may be zero or one. We can store the value in the a. So that means reg a means what? This is one bit. We can store only one bit of value, either it is wire a or reg a. So we can store the one bit of value. Okay. So the default value for reg data type is, so default value is don't care. Okay. So in that we have seen like 0, 1, don't care, and z. No, so 0 is nothing but logical low, logical high, don't care, and z. Okay, so these are the values. So the default value for reg data type is don't care. Okay, so reg data type is don't care. Okay. Next we'll see like so default size is one bit, as I told you. Okay. Suppose like if I say reg a. Okay. So reg a, initial and a equal to, let us take 32. Okay. So a equal to 32 means 32 will be stored. It will be converted into binary. So if you convert into binary, what is the value? 16 0 and 8 0, and next to 2 4 0, next to 2 2 0, and 2 1 0, 2 1 and 0. So you need to take from bottom to top. So that means here the binary value is so 1 triple 0 and a double 0. So that means as this is one bit, so it will store the least bit. So that means here a equal to what? A will store as 0. Okay, so if you are giving 32-bit integer value, so it will store in terms of what? In terms of, it will be converted into binary. So whatever that binary is there, so the least LSB bit. So whatever the LSB bit, that will be stored in the A register. Okay, why? Because the reg A is how many bit? This size is one bit only, so it can store one bit of value. Okay, so it will store the one bit of data. Okay, so if you want to store multiple bits, okay, so we need to go for other data type, that is nothing but vectors. Okay, vectors. Okay, so what is this vectors? So that means grouping of multiple, bits in a single variable. single variable. Okay, grouping of multiple bits in a single variable. So the syntax will be like this. Syntax is data type, and range. Okay, and next variable, range and variable. Okay, so data type can be whatever the data type. We can use reg data type, or we can use in that net data type, that is var data type. Okay, you can use the any type of data type. You can use reg data type and var data type. And the range is so this is msb down to 0, msb down to lsb. Okay, msb down to lsb. So this is nothing but what, down to. Okay, or we can use lsb to msb, lsb to msb. Okay, lsb to msb. So this is 2. Okay, so mostly we'll not use this, mainly we'll use this. Okay, msb to msb down to lsb. Okay, so this is the syntax for this vectors. Okay, suppose if you want to store the value like 3 tick binary, you want to store 3-bit value. So this is 3 tick binary 011. Okay, so how I can write this program, that is module. Let us take one example, module example, reg. Okay, reg, I need to use, that is how many bits, 3 bits, no? So 2 down to 0, let us take a. Okay, 2 down to 0 a, and initial a equal to what, a equal to 3 tick binary 011. Okay, and end module, end module. So that means here a will store. So that is a equal to what, a will store. So so you initialize this has 3-bit value. So that's why a will store like 011, 011. Okay, so this is the vectors concept. Now means suppose if you are giving like 011, what is the index? This is 210. Okay, so that's why at this is msb. Okay, this is msb, and this is ls. 2 down to 0, no? So 2 down to 0 means lsb and msb. Okay, so this is vectors. Okay, suppose if you want to store like 4-bit data. Okay, you want to store 4-bit data. Let us take the 4-bit data as a 4 tick binary 0 triple one, 0 triple 1. Okay, so the standard representation is what, reg 3 down to 0, 3 down to 0. Yeah, this is the standard representation. Okay, so suppose if it is reg 0 to 3. Okay, 0 to 3 comma a. So basically we are not using this. Okay, basically we are not using this type of notation. So mainly we'll use this msb down to 0. Okay, so that means how it will store. So that means so here a equal to what, a equal to 4 tick binary 0 triple one, 0 triple 1. So that means a will be equal to what, 0 1 1 1, and this is the index value 3210. Okay, so so we can say that this is lsb, and this is msb. Suppose if it is 1 to 3, so reg 1 to reg 0 to 3 comma a, if you consider, so it will store like this. So 0 double triple 1. So this is msb, and this is lsb. Okay, so this is lsb. So the order will change. Okay, so order will change. Okay, so this is about the vectors. Okay, uh, so suppose if you consider reg 5 down to 0 m. Okay, m. So that means m is m variable. This is of how many bit? So 5 down to 0 means 0 is included. So this is of 6 bits. Okay, so this is of 6 bits. So let us take the value 0 1. So these values will be stored in the m. Okay, and 1 0 and 1. Okay, so what are the index? 5 4 3 2 1 and 0. Okay, so I want to tell the concept of vector slicing. Okay, so what is this vector slicing? Vector slicing means I can access the individual bit in the vectors. Okay, suppose if I consider module tb, I will initialize this one reg pi down to 0 m comma reg 1 down to 0, let us take n. Okay, so so m equal to what, this value I will initialize, that is 6 tick binary. What is the binary value? 0 double 1 0 triple 1 0 1 triple 1 0 1 and end module. Okay, end module, okay. Suppose if I consider like n equal to m 3 down to 2. 3 down to 2 means what? So I can access the bits of this third bit and second bit. Okay, I can access. So that is equal to n equal to what? So that is 2 tick binary 1 1. Okay, I can access the individual bits in this vectors. Okay, I can access. Suppose like n equal to, if I consider m of 5. M of 5 means what? So that means in n, whatever this MSB bit is there. So that means leftmost bit is MSB and rightmost bit is LS. Okay, so I can store the value. So that is n equal to what? 0. Okay, or we can consider n equal to what? M of 0. Okay, individual bit I can access. That is nothing but vector slicing. So n equal to 1, n equal to 1. This is LS. Okay, so this is LS. Okay. Suppose if you consider reg, so module tb reg 1 down to 0 abc. If I consider abc, okay, so what is the width of these a and b and c? So it is 1 down to 0, so that is it will be a of 1 and a of 0. So that means width is how much? 2. Okay, so width is how much? 2. Okay, so here suppose if I consider module tb reg 1 down to 0 a, and if I keep semicolon and b. Okay, so here you will get an error. Why? Because you stop this statement with semicolon, and here one data type is missing. You not declare the data type. Okay, so we can say that in the Verilog, so this semicolon is nothing but end of the statement. End of the statement. End of the statement. Okay, so here if you see example like module example, let us take I'm initializing the ports within the bracket input a comma b comma c and 1 is to 0 c. Okay, so semicolon and output 2 down to 0, 2 down to 0 sum. Okay, sum, and here, so here also you'll get compilation error. Okay, you'll get compilation error. Why it is compilation error? So here this statement is ended with a semicolon. So in the bracket it should not start, that statement should not end with semicolon. You need to keep so in order to avoid this compilation error, you need to keep the comma. So comma output. So here also, if it is a different length, you need to initialize input. Okay, input input c 1 down to 0. Okay, so input c 1 down to 0. Like this, you need to initialize. Okay, so if you see like reg 2 is to 0 comma a. Okay, let us take a equal to 6. Okay, a equal to 6. So basically how it will store? So that means our compiler will store in terms of binary value. So it is how many bit? 3 bit, no? So it will store like double 1 0. So double 1 0 means what is the index value? So this is double 1 0. So this is 2 1 and 0. 2 1 and 0. Okay, let us take one more example like reg 2 is to 0 a a mm, reg 2 is to 0 b, some a equal to what 6 and b equal to -6. So now how it will store? So a is same what I already told. This is in terms of binary it will store. So a equal to double one double one zero. But b, you see b, b will be stored in terms of 2's complement form. So the normally for 6 if you apply 1's complement, changing 1's to zeros and zeros to 1's, so this is 0 0 1, adding 1 to this, what you are getting 0 1 0. So b will be stored like this 0 1 0. So why? Because in the digital, if you see, negative numbers are represented in three forms. That is sign magnitude form, ones complemented form, and two's complemented form. So in sign magnitude form and ones complemented form, for the zeros, for -0 and +0, you have two representations. Okay, and for two's complementation representation, for -0 and +0, you have only one representation. So that means if you are using sign magnitude or once complemented form, so the compiler will not understand whether to store this that -0 or value or +0 value. So that's why so you need to so whatever the computer or compiler, it will store in terms of what two's complemented form. Okay, so that means in the Verilog or compiler or any computer, if you are doing subtraction or if you want to store the negative value, so that will be stored in terms of what? That will be stored in terms of two's complemented form. Okay, this is two's complement representation. Two's complement representation. Okay, so conclusion. So what are these rate net data type? That means net means what? We are using wire data type, and reg data types. These are unsigned data types. Unsigned data types. Okay. So that means if you want to print this value, you are not getting -6. You are getting 2 only. Okay. That binary representation will get. So while we are doing the signed and unsigned numbers, we can see that how the so I'll show with now, simulation behavioral simulation. I will show the values so that it will show in terms of 2. Okay, so whenever you want to store the negative numbers, you need to go for integer data type. Okay, integer data type. Okay, so if you see next, integer data type. So this reg and wire are unsigned data types. Okay, it will store only positive values. So in order to store negative values, we need to go for integer data type. So in the integer data type, so this width is 32 bit. This width is 32 bit, and it will store which number? Signed number. It will store the signed number. Okay, and what is the default value? Default value is default value is x, unknown. Default value is unknown. Okay, so that means suppose if you are giving the a value 2. Okay, so a value 2 means what? Normally, so it will store a value 2, so integer a and a value 2, so it will store, so that means it will store 0 0 0 up to so on how many bits? 32 bits. So it will store in terms of 32 bits. So this is 0 1 up to so on, this is what? 31. Okay, so 0 is included, that's why uh, uh, so it will store like this. Okay, um, so we cannot use the vectors in the integer data type. Suppose the integer and 3 down to 0, 3 down to 0, a. Okay, so we can't use, so this is invalid. Okay, invalid. Okay, and so next is float data type. Float data type. Float data type is nothing but in order to store the decimal values, we'll use the float data type, or we can call it real data type. Okay, so this is four state data type. Okay, So four state data type, this is so what is the value? This is 0, 1, x and z. Okay, these are the values 0, 1 and x and z. Okay, so this data type used to store the uh, fractional values. Okay, so for decimal or fractional numbers, this data type is used. Okay, so this is used to store the decimal or fractional values. Okay, fractional or decimal values. Okay, so decimal values. So what is the default size of this data type? This is 64 bit. This is 64 bits. Okay, and default value is x. Default value is x. Okay, so you can remember for native data type the default value is high impedance, that is z, and for the remaining like reg data type and the float data type and integer data type, so the default values are x. Okay, you can remember like that. Okay. So so in the Verilog, we already seen the synthesis. What is synthesis? Synthesis is nothing but normally by using HDL, we are creating the hardware by programming. Okay, we are writing the program, we are describing the hardware. Okay, that's why we call it hardware descriptive language. Okay, so that means synthesis is nothing but what? Converting our program. Okay, our program into what? Gate level netlist. Gate level netlist. So gate level netlist means what? So that will be represented in terms of gates. Okay, gate level netlist. Okay. So there are two types of constructs. One is synthesizable constructs and non-synthesizable constructs. Okay. Synthesizable constructs. Okay, and second is non-synthesizable constructs. Non-synthesizable constructs. Okay, so synthesizable constructs and non-synthesizable constructs. So if you see, so what are synthesizable constructs? Whatever the data types like wire, wand, war, war, reg, vectors, vectors, integers, integers are synthesizable constructs, and that means those are synthesizable. So they, by using these data types, we can convert that whatever the program we are writing into gate level netlist. But here, float data type, if you see the float data type, this is non-synthesizable construct. Okay, so non-synthesizable construct. Okay, that is about the synthesizable and non-synthesizable construct. And one more data type is there, that is time data type. Time data type. Okay, so time data type, this is used to track the simulation time. Use it to track the simulation time. Okay, simulation time. So this is track data type. So this is represented like ash. Okay, you want some delay. Okay, so ash colon and semicolon. Okay, and what is the size of this data type? So this size of the data size is 64 bit. Size is 64 bits. Okay, and this is signed or unsigned. This is unsigned. Type cannot be negative, no. So this is unsigned data type. Unsigned data type. Okay, and default value, if you see the default value, so default value is x. Okay, and it is unsigned data type, and we can represent like dollar time. Okay, dollar time, so we can represent like this. Okay, so this is about time data type. And next is arrays. Okay, so next is arrays. So what are these arrays arrays? Okay, if you see the arrays, so arrays are declared before, so if you see the vectors, vectors are declared before the variable, no. So we already seen, so vectors are declared before the variable. Okay, so if you see the vectors example, vectors, suppose example, reg 1 is to 0 comma a. 1 is to 0 comma a. So what is the size? Size means size is 2. Okay, size is 2. Okay, and if it is arrays, how we are defining example, reg a 1 is to 0. Okay, so whatever the size is there, that you are representing after the variable. Okay, so that is the difference between vectors and arrays. In the vectors, you are whatever the size is there, you are representing before the variable. Okay, before the variable. And here in arrays, you are declaring the variable size after the variable. Okay, after the variable. Suppose if you say example, suppose in vectors, we'll see the vectors. Okay, reg 2 down to 0 a. Let us take a value equal to 3. This is 3 bit value, no? 3 tick binary 011. Okay, so that means it will store horizontally. It will store the value horizontally. So what is my variable? Variable is a, and how many bits it will store? 3 bits it will store, and this is nothing but index. Okay, and 2, 1 and 0. Okay, so this is 1 1 0, like this it will store. Okay, and if it is arrays, okay, example of arrays, if you see arrays, okay, reg a 2 down to 0. Okay, so here it will store like vertically. So that means it will allocate three locations. It will allocate three locations. Okay, so three locations like 0, 1 and 2. Okay, so these are used vectors. Whatever the vectors are there, vectors are used for grouping the bits. Vectors are used for grouping the bits. Grouping the bits. Okay, but whereas arrays are not used for grouping the bits. Not used for grouping the bits. Grouping the bits. Okay, so if you see like example, mm, let's take reg a, reg a 1 is to 0. So how many locations? Two locations. Okay, so this is two locations. So this is nothing but array. Okay, initial begin, initial begin. Let us take a of 0 equal to what? 2, and a of 1 equal to what? 3. Okay, a of 1 equal to 3, and n. Okay, n. So how it will store? So it will store in terms of what? So here this is normally it will be, it store like a 2 and 3. So normally it will store in binary. So that means 2 is nothing but 1 0 1 0. So 0 it will store, and this is 0 1 1. So 1 it will store. Okay, so in terms of binary, the last bit it will store. Okay, last bit it will store. Suppose if you consider, let us take module test, reg 2 down to 0. Okay, so how many locations? Three locations. Three locations. Initial, initial, begin, initial, begin. Let us take, so previously it will store like 2 and 3. A of 0 equal to, let us take 5, and a of 1 equal to some 9, and a of 2 equal to some 3 ut. Okay, and end module. You need to end the begin, no? And end module. Okay, so that means vectors means it will store in terms of vertically. So here if you see, three locations are there. So this is location 0, location 1 and location 2. Okay, so normally 5, if it is represented in binary, 101. So whatever the LSB bit is there, that will store. Okay, here 1, and next 9 means it is in binary 10, sorry, 1001, no? So one will be stored. Okay, here also one will be stored. LSB bit will be stored. Okay, and so that means here this is 101. Whatever this bit is there, that will be stored, and 1001. So this is one. Whatever this bit is there, that will be stored, and the next bit is 3. 3 means what? 011. So whatever the LSB bit, this will be stored. Okay, so this will be stored like this. Whatever the so regis of how many bit? Only one bit only. No, so that whatever the LSB bit is there, that will be stored. Okay, that will be stored. Okay, suppose like example, module test. Let's take example to module test. Module test. Reg 1 is to 0, A, and 1 is to 0. Okay, so that means here I initialized. This is nothing but what? Vector. Okay, and this is nothing but array. Vector and array. Okay, so that means how many number of bits? Here 2 bits second stored. Okay, and how many number of locations? 2 locations. Okay, 2 locations and 2 bits. Okay, 2 bits. So here if you consider this one, so that means how many locations you have? So total you have 2 locations. Each location, so each location of is of how many bits? 2 bits. Okay, so that means 2 locations. Okay, so 0 1, so total you have 2 locations. 2 locations, and each of how many bits? 2 bits. Why? Because you initialize the vector, no? So that means each of 2 bits. Okay, so like this you can consider. Suppose example like reg 7 down to 0, mem 31 down to 0. Okay, so this means this is nothing but so how many locations you have? 32 locations. Okay, 32 locations, and each of how many bit? 8 bit. Okay, so with this we can construct a memory. Okay, we can construct a memory. Okay, suppose if you see example module test, module test, module test, reg 1 down to 0, mem of 1 down to 0. Okay, initial, begin, mem of 0 equal to, so total how many bits are there? 2 bits are there, and how many locations are there? 2 locations are there. Okay, 2 locations and 2 bits. Okay, so mem of 0 equal to, let us take 1 second, here 7 down to 0. Okay, 7 down to 0 means total how many bits you can store in 2 locations? 8 bits. Okay, so 8 tick binary 1 0 0. In order to separate or in order for representation of these 4 bits, I'll use underscore 0 triple 1. Okay, and next memo 1 equal to 8 tick h 1 2, 8 tick h 1 2, and end module, Okay, so here how it will store? So total how many locations you have? So you have total 2 locations. You have 2 locations. So so that is location 0 and location 1. So in each location how many bits we can accommodate? 8 bits. So that means 1 0 0 0 and 0 triple 1. Okay, in 0th location, and 12. So 12 is normally a 8 tick h, no? H means normally it will be converted into binary. So we know how to convert hexadecimal to binary. So each and every bit, so this is radix is 16. So you can represent in terms of 2 power 4. So this is what? 0 0 1 0, and this is nothing but 0 0 0 1. Okay, so it will store like 0 0 0 1 and 0 0 1 0. Okay, it will store like this. Okay, so it will store like this. And next, if you see module test, module test reg let us take 1 down to 0, memo 1 down to 0, initial, begin, memo 0 equal to 2 tick binary 1 0. So how many bits are there? 2 bits are there. by using the vector we initialize. How many locations are there? Two locations are there. Okay, and mem of 1 equal to two tick binary 1 1. Okay, end and end module. Okay, so that means how it will store. So like two locations are there. So 0 1 in each location. How many bits are there? So how many bits are there? So two bits will store. So that means in first location 10 will be stored, and second location 11 will be stored. Okay. So that means mem of 0 equal to what? Two tick binary 10. Mem of 1 equal to two tick binary 1 1. Okay. So 1 1. Okay. Like that it will store. Okay. Mm. So same thing. Vector slicing is not possible in the arrays. Suppose if you consider like reg vector slicing uh, reg 1 down to 0 mem of 1 down to 0. Okay, same program will see. Okay, same program. Suppose here the same program. Suppose if you want to access this LSB bit, no, this LSB bit. If I want to access LSB bit separately, okay. So separately, if you want to access, so it's not possible. Okay, it's not possible. So that means vector slicing, it's not possible in the arrays. Vector slicing is not possible in arrays. Okay. So this is about today's session. So today we discussed about the main data types. So those are nothing but reg data types. Reg data types are not nothing but used to store the values. And next we have seen about so this reg and net data types are unsigned data types. So in order to store the values, negative values, we'll use the integer data type and the size and what are the default values we have seen. And in order to store the decimal values or fractional values, you use float data type. Okay, float data type, the default value is 64 bit, size is 64 bit and default value is x. And next we have seen the time data type. That is also unsigned, time cannot be negative. So okay, the size is 64 bit. And next we have seen the vectors. So these reg and net are 1 bit. In order to store the multiple bit at one variable, we'll use the vectors concept. In the vector, so whatever the size is there, so there are two types of sizes are there. One is MSB down to 0 and LSB to MSB. So mostly we'll use MSB down to 0 in the Verilog coding. And so that whatever the size is there, that we define in before the variable. And next we have seen the arrays. So arrays, the difference between vectors and arrays is, so in the arrays we'll define the in vectors we'll define the size before the variable, whereas in arrays we'll define the size after the variable. Okay, so vector slicing, or so we can access any one of the bit in the vectors. Vector slicing is possible in the vectors, but vector slicing is not possible in integer data type and array data type. Okay, so thank you very much. Okay.